Hello, everybody. Good afternoon and welcome to General Mathematics. My name is Dr. Eric Insko, and I wanted to make a quick video just to show you how to get started in this course. So this is an online course, completely virtual. It's supposed to start October 17th, I think. I opened it up a few days early just so you guys could to see what it looks like. And I understand that some of you may be reeling from the hurricane. I know that my house flooded and I had to knock out all my walls, and so I'm still recovering too. So that said, I'll be very flexible with due dates, but this is a very short class. It's only 8 weeks. A little bit longer than a summer course, but then again, you might be taking more courses in addition to this one. So it's a good idea to get started early and make sure that you're comfortable with the homework system. And so the home page on Canvas has the course syllabus. You can go ahead and read that on your own time. It's the standard stuff. The first thing you want to do is take the attendance verification quiz, which many of you have already started. And I'll just preview it so you can see what that looks like. So the first question is, do you have the energy and the time commitment and the internet connection to do an 8-week virtual course? Now, I know that some of you might still not have internet back yet, but it should be coming back soon. And if you don't have it, you got to kind of think about, like, is this the course that you want to sign up for? You still have time to drop if you want. But otherwise, you have the internet, the time management, and the dedication needed to pass this course. The answer should be yes. True or false? All homework assignments will be submitted via MyMathLab, accessible through Canvas, and tests will be on Canvas using the Lockdown browser. So that's true. And then finally, you can email Dr. Insko anytime, and he'll try to respond within 24 hours. That's true as well. Okay, so I'll try to get back to you as soon as I can. Keep in mind that my internet's been going in and out as well due to the storm and whatever Xfinity is doing. But I'll be on campus several days a week too, and there's free tutoring on campus if you live near campus. And you can do drop-in tutoring through the math department's tutoring center. Even on Zoom, you can schedule those, and I'll put a link to that in the course homepage so that there are some resources for you. Now, this course is a pretty fun course. It covers some interesting topics. It's kind of unique in that it starts with like different numbering systems. And so starting tomorrow, as soon as you click on this, it should take you to the homework. And if it doesn't, then you got to let me know. But you should be able to just click on this first assignment, and it should take you directly to the MyMathLab course. And see if I can log on to MyMathLab just separately so you can see what the first assignment looks like. That's not what I wanted. Okay, so it should be this course here, and I have it starting on October 15th. And then I can show you what the first assignment looks like, which is due on 10/22. And again, if you don't have internet, you can email me and I can push that due date back just a little bit. I wanted to preview this. Manage assignments. Okay, and so once you get onto MyMathLab, it should look something like this. And I just want you to know that you have an ebook here. Click over here, e-text context. And in this course, we cover chapters 4 and 5 and chapter 8. And I think we might even do some geometry and counting methods or in voting apportionment. But anyways, we start with chapter 4 in this course. So you'd want to watch this. That has videos and it has PowerPoints and stuff that you can watch to learn these different things. And the very first thing is just starting off with what is the Hindu Arabic numbering system and what were the earlier counting systems. Okay, so if you need to review, you can do that using the e-text book. And let me go back to my assignment. I wanted to show you what the preview looked like. Okay, so my recommendation is when doing these homework assignments to work the problems out on paper and also then enter your answer on the computer. It's something about just writing the problem down on paper helps a lot. So it says a group of ancient Hindu Arabics counted their flocks and noted that the total number in the village in the following expanded notation. Okay, so what this means is it's 4 times 10 to the 4th, right? So let me, like I said, write this out on paper. So 10 to the 4th is what? Well, maybe I should start here. We start with a 9. And then we have 3 times 10 to the 1st. Well, 3 times 10 is 30, right? So we have 30 plus 9 would be 39. And then we have 7 times 10 squared. So 10 squared is 100. Then we multiply by 7, so we got 700. So we have 739. And then we have no 10 to the 3rd. Okay, so I'm just going to write, there's no 10 to the 3rd, so there's nothing with 3 zeros. And then there's 4 times 10 to the 4th. So that would be 4 zeros. And so that should be 40,000, right? So it was 0 times 1,000. So I'm just going to ignore that row there. Okay, so I think that the number is 40,739. And I will try to plug that in and see if that's the correct answer. So stop. 40739. Check answer. Okay, so it gave us that one correctly. Okay, question 2. Fill in the blanks so that the resulting statement is true. So 10 to the 4th is 1 followed by 4 zeros. And where's the 4? And then you have to find that. So it's 10,000. 10 to the 4th is 10,000. I'll check. Cool. Okay, so this just continues on like that. I'll do a few more problems, but I'm not going to do too many. It says our numeration system uses powers of blank. We uses powers of 10, whereas the Babylonian numeration system uses powers of, and I don't even remember, 60 or 20. It says nope, try again. It says the Babylonian system uses powers of 60. Okay, try again. And notice that the system lets you do problems more than once. So even though I got that wrong, I couldn't remember if it was 20 or 60. It did actually let me redo it, and I still got full credit. I think I give you 3 attempts on each problem. Okay, so here's where you're like, what in the world is going on, right? This is when you should maybe stop for a second and go back and look at the e-textbook, right? So we got to go to chapter 4, and then either watch the video or look at the e-textbook. And so this is where we get to understanding the Babylonian number system.
In this video, you will learn to understand and use the Babylonian numeration system. The Babylonians used wet clay as a writing surface. Their clay tablets were heated and dried to give a permanent record of their work. The Babylonian system uses only 2 symbols. A Babylonian numeral that looks like a chevron has a value in the Hindu-Arabic system of 1. The Babylonian numeral that looks like a chevron opening to the right has a value in the Hindu-Arabic system of 10. The place values in the Babylonian system use powers of 60. The place values in the Babylonian system are all powers of 60 down to 60 cubed, 60 squared, 60 to the 1st power, and 1. The Babylonians left a space to distinguish the various place values in the numeral from one another. Let's take a look at an example converting from Babylonian numerals to Hindu-Arabic numerals. Write each Babylonian numeral as a Hindu-Arabic numeral. To change a Babylonian numeral to a Hindu-Arabic numeral, we will represent the numeral in each place as a familiar Hindu-Arabic numeral using 1 for a vertical chevron and 10 for a sideways chevron. Multiply each Hindu-Arabic numeral by its respective place value. Then find the sum of these products. In part A, we are given a pair of vertical chevrons that are in the 60 squared place value. then a sideways chevron and a vertical chevron in the 60 place value, and 2 sideways chevrons and 2 vertical chevrons in the place value 1. This gives us the quantity 1 plus 1 times 60 squared plus the quantity 10 plus 1 times 60 to the first power plus the quantity 10 plus 10 plus 1 plus 1 times 1. Simplifying gives us the quantity 2 times 60 squared plus the quantity 11 times 60 to the first power plus the quantity 22 times 1, or the quantity 2 times 3,600 plus the quantity 11 times 60 plus the quantity 22 times 1. Simplifying in the parentheses, we have 7,200 plus 660 plus 22, which is equal to 7,882. This sum indicates that the given Babylonian numeral is 7,882 when written as a Hindu-Arabic numeral. In part B, we have 2 sideways chevrons in the place value 60 cubed. We have 1 vertical chevron in the 60 squared place value, then 2 chevrons in the 60 place value, and finally, in the 1's place value, we have 2 sideways chevrons and a vertical chevron. This gives us the quantity 10 plus 10 times 60 cubed plus 1 times 60 squared plus the quantity 1 plus 1 times 60 plus the quantity 10 plus 10 plus 1 times 1. Simplifying gives us the quantity 20 times 60 cubed plus the quantity 1 times 60 squared plus the quantity 2 times 60 plus the quantity 21 times 1. Multiplying gives us 4,320,000 plus 3,600 plus 120 plus 21. Adding, we have 4,323,741. This sum indicates that the given Babylonian numeral is 4,323,741 when written as a Hindu-Arabic numeral.
Okay, so I just wanted to show you that these resources are here. I should warn you that chapter 4 is maybe one of the harder ones because we're dealing with these different numbering systems. So they're also kind of interesting from a historical perspective, but it actually might be kind of challenging. And I don't be discouraged by that. Some of the later sections are actually easier and maybe more intuitive than this very first chapter. Okay, so I'm gonna go back to previewing what I've done. And of course, because I'm doing a preview, it made me go, I forgot my progress. Okay, so now we should know how to do this one, right? This is saying that we want a 10 times, and then this is what? First power, or 0th power, first power, second power, third. So 10 times 60 cubed, and then 1 times 60 squared. And then this is a 2, right? 1 plus 1, 2 times 60. And then finally, that is a 10 plus a 1 is an 11 times 1. Final check. Okay, so by watching that video, we're able to do the next question. The next one's even easier, right? 4 cubed. Wait, we know how to do that. 4 times 4 times 4 is 4 times 16, which is 64. Okay, so again, the Babylonian question was really tough. The next one's really easy. Express the given Hindu-Arabic numeral in expanded form using the multiplication symbol and the math palette as needed. So I think what this is saying, what it wants us to do is write 7 times 10 plus 5. That's incorrect. Okay. So now I need to go back and review what the expanded form is. Or I can look at view an example, right? So maybe I don't have to go back and watch every video. So here it tells us how to express the given Hindu-Arabic numeral in expanded form. So with these exponents, continue. The 5, the number 35 is placed as a 1 value. 3 has a place of 10 value. Continue. So right? We want to do 3 times 10 to the 1, and then 5 times 1. And so I had the right general idea. I had 3 times 10 plus 5 times 1, but I guess what it wants us to do is write it as 3 times 10 to the 1 plus 5, and not just 5, but 5 times 1. Okay, so that's what I'm missing. So I will go back and plug that in there and plug in a times 1 there. Check answer. Okay, so there's a good resource while doing these online problems. Okay, so write this one in expanded form. Okay, well, this is going to be 5 times 1,000, and that 10 to the 3rd, and then plus, and I don't know if I need to do this, but 0 times 100, so 10 squared, plus 7 times 10, plus 0 times 1. Okay, and I don't know if I need that there, but I'll just check it. And hopefully the system has some built-in flexibility and knows, like, if you just put 7 times 10, it would have been okay with that. Okay, and this is the last question of the section. It says, express the given expanded form as the Hindu numeric value. So this is going to be 4,000 plus 0 times 100 plus 0 times 10, and then plus 3. So 4,003. Okay. And so that, I guess we just did your entire, no, we didn't. There's still some more homework problems here. Question 9. Use the table on the right to write the Babylonian numeral as a Hindu Arabic numeral. Okay, so what do we have here? We have a 10 plus 2 1s, so that'd be 12. So 12 times 60 plus 2 times 1. So 12 times 60 plus 2 times 1. I'm going to need a calculator to do that. I haven't had enough coffee today to figure out that question yet. Okay, 722 it says. Okay, so where did my homework go? There, okay. So 12, so 722, check answer. Good. Okay, we haven't done anything with the Mayans. So either we want to do an example or go back and watch some videos. I think I'm going to go back and watch the video, and actually I'll leave you guys to watch the video now. Hopefully this helps you get started. It'll be basically, we've gone over the Babylonians, Hindu Arabic, and then some Mayan numbers, which will be similar. You just have to read the book and it'll tell you exactly how to do that. In fact, here's a question we have to convert from Mayan to Babylonian and so forth. Okay, so good luck. If you have any questions, feel free to email me. These assignments should show up on October 15th. You should be able to log on, and I'll check tomorrow morning to make sure that's the case. And if you haven't bought the access code yet, I think you get 2 weeks free access when you sign up for the course. Okay, thanks. Have a good day. Bye. Share.